Alright guys, the last electron configuration that you will be learning is how to write where the electrons are in an atom if it has lost or gained electrons. Okay, so we've alluded to what ions are in previous units. When you did the isotopes where you were counting the protons and the neutrons, you may have noticed that I put a different number of electrons in some of those. Okay, that represents an atom that has lost or gained electrons. Okay, so the definition of an ion is an atom that has lost or gained electrons. Atoms prefer to have a full or empty, and they don't technically have an empty outer shell, it just means that the last one kind of is no longer there and the next one behind it is full. Outer shell, outer energy level. Okay, this makes them more stable. And that is what life is all about. Everyone's trying to just be more stable. Okay? So metals, and remember where metals are. They are your alkali metals, alkaline earth metals, transition metals, and even some over here in this P block. Metals typically lose electrons. Okay, so they will typically become positive, right? Because if you're losing the negative particles, then you're going to have more protons. So you will be a positive ion. Nonmetals typically gain electrons and they become negative, right? Because if you gain the negative particles, you're going to gain that negativity. My lights like to go out on me. So afterwards, after they have lost electrons or gained electrons, they then look like a noble gas, right? Because your noble gases don't react, they're stable, they have a full outer shell of electrons. Okay, which was the whole goal. Everybody hopes they can have that full outer shell of electrons. So, your ion configurations, a good way to check if you've done it right is it should match one of these 6 noble gases. Okay, so let's just do a few examples. We're going to do 2 metals and 2 nonmetals. So sodium plus calcium 2 plus, nitrogen 3 minus, and bromine minus 1. Okay, these are the ions that we're going to do as examples, and then you'll have some practice problems to do on your own. So let's first decide, before we even try to deal with their electron configuration, let's decide if they're losing or gaining. So if you see a positive charge, that means it has more protons. This sodium has 1 more proton. Okay, but it didn't gain protons. It can't really do that because we're not studying nuclear chemistry right now. Okay, so it lost how many electrons? 1 electron. Calcium is positive, so it has 2 fewer electrons, so it lost 2 electrons. Nitrogen is negative, okay, 3 negative. That means it gained 3 electrons, and bromine with the negative 1 means it gained 1 electrons. Okay, so what you're going to do is you're just going to write the electron configuration, and then you can deal with it after you've written it, what you need to do with those ending electrons. Okay, so sodium, where are you, sodium? Right here. It's going to end in 3s1, so just kind of mindlessly go through your first 2 energy levels, 1s2, 2s2, 2p6, and then 3s1. Okay? But we said he's going to lose an electron. So just take that out. If you can have the forethought to not write that, you don't even have to write that. You don't have to write that and show me that you're crossing it out. Okay? So calcium over here, 4s2, okay, but we decided he's losing 2 electrons. So are you even going to need to write the 2 electrons in that 4s sublevel? No. So you're going to go 1s2, 2s2, 2p6, 3s2, 3p6. We are now at argon. If you were still continuing writing calcium, you would have written 4s2. But you don't need to do that because calcium lost 2 electrons. Okay? And again, you don't have to write that and put the X. You can just write it out as that noble gas configuration. Okay? Nitrogen's over here. He's going to be gaining 3 electrons because he's a -3. So you can either write out nitrogen and then add 3 electrons to it, or you can realize he's going to be 1, 2, 3 gained electrons will put him at neons configuration. Okay, so 1s2, 2s2, 2p6. Nitrogen should be 2p3, but he's gained 3 electrons. So 2p4, 2p5, 2p6. Bromine gained 1 electron. That's going to put him over here at krypton. Okay, because remember, everybody wants to have that full outer shell. Bromine gaining 1 electron puts him right there. Okay, so krypton and bromine both end in 4p. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Don't forget to dip down to 3d10. Bromine should be 4p5, but he's gained an electron, so he is 4p6. Voila. Now, a little trick question. If you wanted to write the noble gas configuration for something that already had a noble gas configuration, you can't just write krypton and call it a day. Okay, it has to be the noble gas above it. So the noble gas configuration for either a bromine ion that looks like krypton or an actual krypton electron configuration, you have to give argon as your noble gas and then write that valence shell. So argon, 4s2, 3d10, 4p6. Okay, and there's your 8 valence electrons from your 4th energy level, just like bromine wanted when he gained that electron. So this is the point where you need to turn all the way to the very back of your packet. This is page 8 for 2018. And go ahead and complete this bottom section about ions. We've written the definition of an ion. We've written why they become ions and how you try these ion configurations, and make sure you put who they resemble. What noble gas are they now looking like after they have lost or gained electrons?